Hello everyone! Today is the time for the next hardware upgrade, and it looks like it will be really interesting. Let's go! Quick unboxing, and we can check what is inside. Small boxes, bigger, and now we have the Spindle motor, which is 500 watts air cooling spindle motor with a lot of the collets. It's there exactly 14 pieces ER 11 collets, 52mm bracket for CNC and engraving machine. All this pack is including PWM controller, which theoretically should give the 100 volt DC output maximum for the motor. But first, I want to test the spindle motor with my power supply to make sure it's working fine. I want to also check the noise level and if there's any vibration. Okay, power supply is online. Let's start from 12 volts. That's surprisingly good. It's really quiet. No vibrations. As you can see, drawing not too much power, but it's just 12 volts. The power supply is maximum 30 volts. It means I can't test in the full range, but it will be enough to give me some yeah, 24 volts. And it's just the 6 watts. Unloaded, of course. Because theoretically is 500 watts. On the load we're going like to 60, 70, 90, more than 100 watts. And be honest, yeah, first impression is really good. I know what I'm doing looks not safe, but yeah, I'm really carefully touching the rotating components. And 31 volts is absolutely maximum from this power supply. How far are we going? Yeah, it's really difficult now to slow down and put the load. I don't want to risk. And the current limit was only 1 amp. Let's try with the 6 amps limit. Yeah, it's much better. Much better. It was close to 200 watts. And it's really, really heavy and feels solid. Like I said, it's no vibration. It's really quiet. I like it because the original spindle, which is like 1/3 of the size of this one, it's really noisy and is vibrating, and I can say it's even not worth few pounds, but it comes together with the whole kit for the CNC machine. Okay, that test, I can say it was successful. The next step will be connect to this PWM controller, and we see how it will behave. As you can see now, as the comes from China, built in China, and I always check, double check with everything comes from China, especially low budget. I don't want to say is the stuff from China is bad, because almost everything is made in China. But unfortunately, as they want to save money and to sell really cheap products, they save on the materials and the components, and sometimes that creates some risk. At the front, the first problem is no polarity mark on the output. You can see it's just the motor label, and it's nothing positive, negative. Something in Chinese on the label above the motor, but I don't know what does it mean. It should be clear information, plus, minus, or positive, negative. Because the spindle will rotate in the wrong direction. And when I try to deal with the and start using this, it will be not good for the bits, because then it should rotate in the proper way. We got the collets. Smallest is the 1 millimeter, then 1.5, 2, 2.5, 3.5, 4, 4.5, 5, 5.5, 6. It's like half mil steps up to 7, from 1 to 7 mil. And of course, first impression, they looks really good, like for this price. Unfortunately, it's no longer available on Amazon. This one is the separate order, also from Amazon. I get some Genmitsu 40 pits end mills for the CNC rotor. It's the 1/8 of inch chunk CNC cutter, milling, graving bit set, and that set was cost me £30, which is really good price. Okay, we need to find the help on the website for the connection, and again here they put on the power plus and minus, which is ridiculous because this is the AC input, and it doesn't matter, it's not the plus and minus, it's AC, alternated current. 50 times per second is switching plus and minus. Motor, fortunately, has the red and black wire. And we can assume is the red is positive, black is the negative. On off, I'll keep this this wire connected. This means it's just permanently connected. Potentiometer, as you can see, is exactly the same, but in my controller is no input from 0 to 10 signal. I check the first installation of the case, because that's important. We don't want to get electric shock. And the next problem here is no connection to the ground. As you can see, we got the 2 pins for power input, 2 for motor output, and 2 for on-off. No ground connection. That's I need to resolve this problem. Never connect the main powered device without the grounding case, because that's the metal body which could easily, for any reason, go live and will kill you. That's really danger, is the full live voltage. In Europe, it's like 240 volts. In US and other countries, of course, depend on your location, would be 120, 115. But in Europe, we got 240 currently. Old standard, it was 220. And again, like I said, I just checked the resistance between the pins, make sure we got the proper insulation. That's the first step what I can do to power up without really worrying about electric shock. But still need to be really careful with this metal case, because it's not grounded. For my testing now on bench, I will not connect this to the ground. I will check as it is, but will avoid touching the metal parts. Again, quick test with the power supply, and I'm checking the direction of the rotation, spindle rotation, to make sure if I connect the black negative, red positive, that will spin with the same direction. Put the arrow there, so you can see just a visual check. It's really easy for mistake. We don't want to do this. As you can see, the whole set looks really, really nice, to be honest. All dimensions, good. You can say it's really, the quality is really not bad. I'm now talking about the spindle motor collets and the brackets. I'm not talking yet about the DC controller, but that's could be different story. Okay, let's power up and see what happens. And everything I connect exactly the same way as the diagram shows. So you can see red, black and power. I'm using quick connector with separate fuse. Just in case if something blown. Now when I close this lid is live. And okay, looks good. Got a proper rotation. Direction is okay. Arrow is pointing to the right direction. And remember always when you play with the live, if you're not sure what you're doing, don't do this. Please. Because that's danger. I got a many years experience with that. And mostly I know what I'm doing. I don't want to say it's as the mistakes not happening. Because we are just the people and mistakes always could happening. Still motor behave really good. Even with the 48, 49, 50 almost volts output. I was optimistic because I want to use my insulated 48 volt power supply, but no, it's still getting relatively slow. I not measure the RPM now, but definitely it's not the fast enough for working with all materials. I want to use to the minimum 15,000 RPM speed. But let's go higher. Unfortunately my hand is covering now the multimeter. Sorry for that. I was probably looking just on the multimeter when I record this video and not... But definitely I was going to the maximum. You can see the potentiometer reached the max. And still is almost zero vibration. That's really positive. I really like it. The spindle behave really good. And it's quiet. And it's really quiet. As you can see, I'm just testing with a few different voltages because I want to make sure again, check if we got any voltage between chassis. Fortunately, it looks okay. It's no voltage present on the case. Load test, risking my fingers. That's not smart. But I never say I'm really smart. I try to not kill myself, but yeah, when I'm looking, sometimes what I'm doing is... But yeah, okay, I try be, funny, but I'm really carefully doing this because I don't want to break my fingers. It's no sharp edges or something. It will just generate a little bit of heat if I squeeze too much. Okay, power down. And it stopped immediately, as you can see. Let's mark where is positive, definitely, confirmed. Positive confirmed and negative confirmed in the same. I even prefer to use a different color, just in case if partially scratch, I can see still red and blue. And I also put the color markings on the plastic connector at the front. Just in case. because remember, just this is paint marker should stay, but if you use I don't know IPA, but like I sometimes use the flux off cleaner to clean some surface if I want to put the label, then definitely that remove this paint. Okay, now the next step, I know it's working, but still I'm really don't know if it's safe to use. There's no voltage present in there, even it's not loaded now, which okay is good. It's not connected, but remember inside is the big capacitor, and this electrolytic capacitor could store a lot of energy, and that gives you really bad shock, and it's really enough energy to stop your heart. Wow, my warranty gone. I don't care. I want to be sure it's safe. As you can see, good point, we got the fuse on board. That's good. No less risk of fire, but look on that. I'm just checking now, the still is 265 volts, and it's like a few minutes disconnected from mains. It's slowly going down. It's mean it's no discharge resistor here, and that's really bad. That's really bad. It's really not safe. You can touch those diodes now, and you'll get nasty, very nasty shock. I got this few times before, and trust me, you don't want to do it. Even will leave the burn marks on your skin. See, still 262 volts. This capacitor is discharging us really slowly. It's just this probably like quiescent current going to the IC. They put some silicon to cover some ICs. Top secret part. What I can say about this build, we got this small yellow transformer which provides galvanic insulation between the potentiometer part. And okay, do you remember when I said about the cost savings? Now here it is. Here under this probably one is the MOSFET for the PWM, and one is diode. Currently I'm just guessing, but that's, you see, I show you the proper thermal pads which provide thermal conductivity to the case, which in this situation is working as a heatsink and provide the cooling to the transistor and other power components. We got just two power components, but they are connected directly to the capacitor. If you could see this big traces going from this black barrel which store your energy, and is connected straight to those components. And at this moment, that's sheet of plastic which is there provide you some insulation, but the first problem is not proper thermal conductive. It's like using the thermal paste for processor in the PC to make the good contact thermal joint. And let's check what's happened if I use the soldering iron to touch. And it's bad. Unfortunately, when I touch this material, I was afraid it's just like that. It's not mica, because the old style, I think, is not really in use now. It's like mica insulation pads under transistors, but it's really old technology. It's required also the thermal paste. It's no thermal paste, it's normal plastic. Sheet of plastic, like the foil, which, as you can see, is melting straight. How do you know if they're under load? If you leave your machine running, making some cutting or engraving or whatever for, I don't know, hour, and this power components will reach the temperature when this plastic start melting and is shrink, and then you got a contact. In the best case scenario, you make some short and your fuse is blown. And that is very important to connect your shield, hold the metal casing always to the ground. It doesn't matter what device you're using, when it's connected to the grid, connect also. Make sure your connection, even if you got the 3 pins plug, or many times on the controllers like that, it will be third screw terminal for the ground, but make sure this terminal is connected. The few times I found it was just floating, was connected to nothing. In case if something happens, that is the path where the all danger current voltage will follow, and in the worst case, your fuse blown, or you will blown some component inside. That's fine, but it's not kill you, because the case is grounded. If you have the RCD, which really recommended any devices in the workshop. I have in my workshop the RCD, which is differential, which is detect the leak to the ground. It was about 30 milliamps, which give you some shock, but 30 amps will not kill you. And if is detect 30 milliamp leak, it will disconnect the circuit. Look how long it is. I made this some stuff, I make some measurements, and still it's 250 volts. Yeah, and like I said, the one is just the diode. Theoretically, give you like some separation. Now, before I can do anything more, I need to discharge this capacitor. Just for the safety. I don't want a nasty shock. And for the safe discharge this capacitor, I will use my probes. And as you can see, I put the 15 ohm resistor to just discharge this cap. See? 15 ohms and it's still spark going because it's 260 volts. Seriously. You see that spark? You don't want that current going through your body. It will give you really nasty shock. Now it's really safe. 5 volts. Just 5 volts. It's okay. Now it's fine. Now I make the short, just to make sure, because if you see that it was slightly ramping up, maybe other capacitors was kept some charge, but now is no chance to go. But funny bits, the whole this part is insulated, got a small transformer which insulates from the circuit, but the ground is the same. It means the negative from the capacitor is also connected to the negative on the potentiometer. It means still some way is connected to the power. As you can see, the hand solder, it was from the bottom side, which okay is correct, but I don't like it because it's not going through the every through hole component. Should the solder leak on the other side. In some APC standards, you need to cover like minimum 85%. And because it's power component, I don't like it. I just put the extra solder to make sure is the joined correctly. I'm doing the same on the diodes. The one reason is the connection. The reason number two, your tracks. As you can see, they're relatively big tracks. They give you also the cooling. Side effect is just the cooling, because as the big copper area will just help with the heat dissipation, and after that I'm sure the critical points are soldered properly. Maybe it's just me, maybe I'm overthinking, but it's my point. I prefer to do this and make sure that everything is safe. I don't want to fire or some surprise or fireworks. Like in the UK we have the bonfire night. No thank you. You know, the many times on the production line when the people soldering this, they of course doing quickly, really quickly, and in this case I'm not sure it was enough heat transfer to properly melt the solder. It was just, as you can see on the other side, which partially is correct, it was not looks bad, but then I will do the same from the both sides, because that's the proper way. When you melt, it should be melt on the both sides, because we don't want to create the dry joints or something like that. I set the soldering station to 450 volts. And like I said, maybe it's just me, because on my work I'm dealing with the massive currents when we build the PDUs to distribute like megawatts of power, or in electric vehicles when you're putting like hundreds amps. Maybe some people will laugh and say, yeah, why you doing? Well, but it's just me. It's just for the peace of mind. The next problem, what I found, the gap between the PCB and this metal case, the gap is really small. And even if the good power supplies, like the computer power supplies, you got the insulation sheet between that. It's nothing here. If for any reason you apply the pressure, that aluminium case is really easy to bend, and then you can touch to the PCB, to the live components. Here I'm just used the Kapton tape. Kapton tape is really good thermal insulation and electrical insulation, and give me extra peace of mind. I can understand they not doing this way, but the simple piece of plastic, the same material what they use for the transistor, that could be insulator on the between the PCB and this case, but not on the power transistors. Now all the bottom part is covered, is insulated, and I will sleep better. That green material, that thermal part which I'm using, that's really interesting, because now it looks like some foil or plastic. I just removed the foil cover, but this material is really interesting, because when your components are getting hot, it's changed state to liquid, and it's really fill the gap between component and the heatsink. That is really special thermal part. I'm using this a lot in other projects, and that's the reason why I use here. But you can find a lot of the really cheap thermal parts, and anything what is connected to that high voltage, it should be properly insulated. That's the main point. That's the safety. Okay, and it's the time to put everything back together. Don't forget to bolt it properly, your power components to the heatsinks. Important. They need to be flat as possible to the surface of the heatsink. It's simple design, and it should be enough, definitely. I'm the most of the time PWM controllers are really efficient, and this means it's not generating too much heat. All modifications done, and now I'm sure it's much safer. Okay, and that's it for today. Please let me know in the comments if you like that way of my explanation of the subject when I'm working on something, because I'm trying different ways. Try to make some scripts, but it's not always sounds natural, and I think I can explain much more when I'm doing this way, but I'm aware not everyone could like when I'm talking too much. Please let me know in the comments, and let me know if there's something like that is interesting for you, because in the next episodes I got a lot of the modifications on the devices, IoT stuff, and like that. Okay, thank you for the watching, and see you next time.